We're going to find the radius of convergence for this problem. This problem is number 9 from last night's homework, so you did the first steps already. You found the ratio of a sub n plus 1 over a sub n, and that simplified down to 4x plus 1. The limit as n goes to infinity of a sub n plus 1 over a sub n equaled 4x plus 1. This is not 0. This is not infinity. So now our job is to figure out which values of x force this thing to converge. And we're going to use the same trick we used at the beginning of this section of this chapter. When we looked at infinite sums in the very beginning, we said that they were going to converge as long as this value here, the radius, the ratio, was between -1 and 1. It's the exact same idea. Anytime you find one of these limits and you get down to something like this, and it's not 0 and it's not infinity, you just want to make sure that whatever you end up with is between -1 and 1. We have to find the x's that force this to be between -1 and 1. So I'm going to take that expression and just set it less than 1 and more than -1. And now we're going to use algebra from literally 8th grade to solve this. I need to get this x by itself. So I'm going to start by subtracting 1 from everything. Whoops, that's 0. And then divide everybody by 4. And come up with the idea that as long as x is between 0 and -1/2, this limit will be between -1 and 1, and this power series is going to converge. Now the question, this is not quite the interval because we don't know what's happening at the specific endpoints just yet, but I can definitely use this information to find the radius. Smack dab between -1/2 and 0 is the value -1/4. That's going to be my center. And then -1/2 and 0 are both 1/4 away from the center. So my radius ends up being basically whatever half this distance is. My radius is 1/4. So to recap the whole concept, once you find that limit, if it's not 0, if it's some expression, you're going to always set that expression to be between -1 and 1 and solve it, and then take half the distance between those endpoints to get the radius.